Alright, today we're going to take a look at using properties of exponents. In our book it's section 6.1. My class, I'd like for you to copy down these labels and the general example of each of these. So to start off with the product of power. So if you have a to the n and you times it by a to the m, of course, to do this, these bases have to be the same, and if the bases are the same, then the rule tells you that you just simply add their exponents. Alright, so here's an example. 2 squared times 2 to the third is going to be 2 to the 2 plus 3, or 2 to the 5th power. Now we could go on and evaluate that, but we're not going to address that at this point. Alright, so on your paper, go ahead and try this one. 3 to the third times 3 to the fourth. And you should have gotten 3 to the 7th power. That's a pretty thick line there. Let's back that off a little bit. There we go. Alright, here's another one. Y squared times y to the 4th. And that would be y to the 6th power. So we're going to add the 2 and the 4 and get 6. And the y doesn't change. Now, a common error that you might have on this one would be to treat these numbers as decimal numbers and as exponential numbers. But as you can see, we don't do anything with the 3's. This doesn't turn out to be 9 to the 7th. You don't multiply the bases. You treat them like exponential numbers. And when you multiply exponential numbers, you can only do it if the bases are the same and the base stays the same, and you simply add the exponents. Okay? So the next one, and I'm wondering if we're getting all of this in. See if I can move this a little bit so that we're getting all of it. There we go. Alright, it's called the power of powers. The general case is a raised to the n and then raised to the m. So it's sort of an exponent on top of an exponent, or power raised to a power. And the rule tells us that the base stays the same. We're simply going to multiply their exponents. So here's an example. 2 to the 5th, then raised to the 3rd. The 2 stays the same, and we multiply 5 times 3, and we get 15. Okay? On your paper, go ahead and work this one out. And you should have gotten x to the 12th power, because that's what 3 times 4 is. Okay? All right, here's the power of products, and it's a times b, that product raised to the m power. What the property tells us is that basically we're going to take the exponent on the outside and multiply it by the exponents that are on the inside. Well, you say there is no exponent. Well, yes, there is. If there's not an exponent, everything's raised to the positive 1 power. So I'll go ahead and put that 1 in there that you can see. And of course, 1 times m is m, and then 1 times m is, I think I did the b first, is this m. So basically what we're doing is we're multiplying the exponent on the outside by the exponent that's on the inside, and we can do that across multiplication. We cannot do that if that was add or subtract here. It only works with multiplication. Okay, so here's our example. 3xy all raised to the 3rd power. Okay, so we're going to go ahead and visually put these 1's in here. And you'd have to multiply each of those exponents by 3. So 3 to the 3 times 1, or 3 to the 3rd power, and that's what 27 is. And x to the 1 times 3, 3. Y to the 1 times 3, 3. We get 27 x cubed y cubed. You try this one. Okay, I'm going to go ahead and put in the, well, that didn't look very good. Let's take that little mark out. Going to go ahead and put the 1 there that we know exists, and we're going to multiply the exponents by 3. So we have 2 to the 1 times 3, 3. And x to the 2 times 3, 6. Now we wouldn't want to leave 2 to the 3rd power. If you can actually do the multiplication, we want you to do it. We didn't do it up here. I told you I'd address it a little bit later. So 2 to the 3rd is 2 times 2, which is 4 times 2, which is 8, x to the 6th power, and that would be that answer. Okay, here we have the quotient of power. So we have a quotient you think of it can be thought of as a fraction. And of course, you'll notice we do have the same bases. So when you divide like bases, what this rule is telling us is you take the top exponent, you subtract the bottom exponent. Notice we're not canceling these a's. We're not doing anything with the a's. It all happens with the exponents. Okay, so this is going to be a to the n minus m, or the top exponent minus the bottom exponent. Okay, here's our example. X to the 5th divided by x squared. The bases are the same. Then we just take 5 and we subtract 2 and we get x to the 3rd. Okay, so let's try a couple. And putting in the 1 here that we know exists, this is going to be y to the, I'll change that question mark to the 2nd power. That'll work. Now here, try this one. Please resist the urge to cancel these 2's. That would be treating them like they're decimal numbers. They're exponential numbers, and the only way to divide exponential numbers is if they're the same base. And since they are, the base stays the same. And 4 minus 2 is, my question mark to a 2 works again. And we'll take that even further. 2 squared is 4. Okay, and one more. Okay, now here it's a little bit different, but I'm going to still work with my question mark a little bit. I have 3 minus 5, x to the 3 minus 5. So it's the top one minus the bottom. Resist the urge to put the bigger one up front. Now sometimes I find students doing that. You don't want to. You want to put the top one minus the bottom. Of course, that equals x to the negative 2 power. Now, for right now, we're going to leave that alone, but later on in this lesson, we're going to deal with negative exponents, but we'll just leave that as it is right now. Okay, the power of quotients. Okay, so you have a quotient, a fraction, and it's raised to a power. Okay, remember now these exponents are 1 in here, and everything's got an exponent. So basically what you're doing is it's the m times the 1, or it gives me 1m, a to the m, and then m times 1, b to the m. So we sort of distribute that m through the parentheses there, multiplying the exponents that we have in there by the exponent that's on the outside. Okay, here's our example, and I'll write in the 1 so that you can see them, these exponents. And 3 to the 1 times 3, or 3 to the 3rd power, and that's going to be 27. We can do that multiplication. And we have x to the 1 times 3, x to the 3rd, and of course it stays like that, 27, x to the 3rd. Go ahead and try this one. Okay, well, we distribute that 2. 2 times 1 is x to the 2nd. And then we have 2 times 2 to the 2 times 1 times 2 to the 2nd power, and y to the 1 times 2, 2. And of course, we've got a little more work to do right here. So our final answer is going to be x squared over 4 y squared. See, we can actually do the multiplication that's implied by the exponent there, so we want you to do that. All right, try this one. Okay, this is going to be 3 cubed over x to the 3 times 2, 6, but we don't leave 3 cubed. That's going to be 27 x to the 6th. Okay. Negative exponents. Okay, so in general, a to the negative m, or if you have a negative exponent, you can't leave it that way. It's not simplified if you have negative exponents, so you can't leave negative exponents in your final answer. We have to deal with them. Okay, so I'm going to sort of dot in a fraction bar here and put a 1 over here, because anything is itself over 1. We can imagine that, and I want you to think about that. And everything has a coefficient. Every variable has a coefficient. Of course, a is a letter, and we could imagine a 1 times a to the negative m if we wanted to here. And so as you can see, this a to the m is dropping to the denominator. The 1 sort of disappears down. 1 times a to the m. The most important thing is, though, that the sign on the exponent changes to positive. And where this 1 is, well, that's that 1 that we understood to be in front of a to the m when we moved it. And of course, it leaves as a factor and it comes down as a factor, and of course 1 times that is itself. So a to the negative m equals 1 over a to the m. And again, those negative, or those understood 1s, I think sort of help us understand the where this 1 is coming from and why that's on the bottom as a factor. Okay. All right, the other half of this is that if you find something raised to a negative power in the denominator, well, then what we're going to do is we're going to take that and we're going to move it to the other place. So if it's found negative, it has to go to the other side of the fraction bar. And again, there's a 1 in front of this if you want to imagine it, and that's the one that it's over 1. And of course, if it's over 1, we don't have to write it. So we sort of take that out, get some cooperation from the eraser here. All right, so kind of in general, then wherever a term is found with a negative exponent, well, then it just needs to cross the fraction bar and it changes sign. So a to the m in the numerator is a to the negative m in the numerator is a to the positive m in the denominator. If you have a to the negative m in the denominator, it goes up top and it arrives as a factor, and you get a to the m. Okay. Now, think back of that problem we worked earlier where I said we're not going to leave that x to the negative 2. This was the problem that we saw on an earlier screen. And so this answer, that answer further simplifies to be 1 over x to the positive 2. So we have x to the negative 2. We'll imagine it as a part of a fraction. We'll move it down, and then the understood 1 appears because you have to have something in the numerator. Okay, so several examples here. This one right here, this first example, we need to understand that exponents only reach to whatever is to their immediate left. So this to the negative 2 doesn't affect this positive 2 at all. That positive 2 raised to the positive 1 power. So that's only on the x. Okay, so that x would have to drop to the denominator. The sign would become positive on its exponent, and the 2 remains where it is unchanged. So this would be 2 over x squared. Okay, let's drop down to this one. Now here the parentheses is raised to the negative 3. That negative 3 is on the parentheses, so it's on everything that's inside the parentheses. So I move the entire parentheses to the denominator, and that would be 1 over parentheses 3y cubed as a medium step there, and then I would distribute that 3 to the y and to the 3, and of course 3 to the third power is 27, and y cubed is y cubed. And what appears in the numerator, why the understood 1 in front of this becomes the numerator. Okay, all right, over to this example. Now here the only thing that's raised to the negative power is in the denominator, so I move it up to the numerator. It arrives as a factor. There is no need for us to put over 1, but there is a 1 there, and when we leave, it shows up, and of course anything over 1 is itself. That leaves us with the final answer of 4x to the third. Okay, and this one, here we see we find negative exponents both in the numerator and the denominator. So this one goes to the bottom, and this one goes to the top. And when this one gets to the top, it's going to be 5 squared over y cubed, and of course 5 squared is 25, and that gives us our answer. All right, let's try a couple of these. Okay, in this one, our only issue is found in the denominator, and it is a factor. One can move factors up and down, and it arrives as a factor when it gets to the top. So we'd have x, y, and the negative change to positive 2, and the 2 stays down. It's raised to the positive 1 power. No need to move it. It is not connected to that negative 2 power. It is to the first power. Okay. Go ahead and try this next one. All right, there's a couple ways we can do this. As you see, the entire numerator is in parentheses raised to the negative 2 power, so I'd like to see this whole thing go down. It arrives as a factor. In the denominator, the only thing that needs to move is the y, and it has to come up to the top. So I'm going to have y squared on top, and then I have 3 times this parentheses 2x to the third, which is now raised to the positive 2 power. The sign changes. The next thing I have to do is distribute this 2 to the exponents that are inside. So this is equal to y squared 3 times, well, the 1 that's here, so this is going to be 2 to the 1 times 2, 2. 2 to the second is 4. And then it's x to the 3 times 2, 6. And then go ahead and multiply the 3 times the 4. We have y squared over 12 x to the 6th. Okay. Zero exponent property says that a to the 0 equals 1. Now I'd like to restate that and say anything, okay, using the a there, anything raised to the 0 power is 1. There's a lot of smoke screens that we can throw up here that people have a tendency to get blinded by. Okay, so if it's x to the 0, it's equal to positive 1. Parentheses, doesn't matter how big the things, what's inside the parentheses, if it's all in parentheses raised to the 0 power, all equals positive 1. Even if what's in the parentheses is negative, negative 3 raised to the 0 equals positive 1. A really big fraction with negatives and exponents in it, regardless of what's inside its parentheses raised to the 0 power, the entire thing is equal to 1. In this last example, remember that 0 power only goes to the thing that's on its immediate left. So this, as we found earlier, is equal to positive 1, right? So this is positive 1 times negative 4, and of course that turns out to be negative 4. Go ahead and give me the answer to this one. You guessed it, positive 1. Regardless of the negative, regardless of these things raised, I don't have to do anything in here. It's parentheses raised to the 0 power. It's equal to positive 1. Okay, evaluating means to do the multiplication that's indicated by the exponent. Okay, example, evaluate 2 to the 3rd raised to the 4th power. Well, we'll first off treat this as exponential numbers, and it's power raised to a power, so we multiply the 3 times the 4, we get 2 to the 12th power, and that's going to be, when you do the multiplication, 4,096. You take a minute to evaluate this one. Okay, so after working that one out, you should have got 6,561. All right, let's move on. Here's an example, a fraction raised to the 2nd power. Of course, we're going to use that the power of quotients. Okay, so we're going to distribute that 2 to each of these. 1 times 2 is 3 to the 2nd. 1 times 2 is 4 to the 2nd. 3 squared is 9. 4 squared is 16. You try this one. And 125 over 512. Okay, let's evaluate this one. We have negative 5 to the negative 6 times negative 5 to the positive 4. Instead of trying to figure out what each one of these is, what we need to see is these are like bases. So treat them like bases. The same base, parentheses, negative 5, raised to the negative 6 plus positive 4, or negative 2 power. We imagine it as itself over 1. The 1 in front here, we take this to the bottom, this 1 disappears, and the 1 shows up over here. I don't know what happened to that 1, how it's kind of faded. That line's actually moved for some reason. I don't know why. But we have 1 over negative 5 to the 2nd power. Now, when we distribute this 2, we give it to the 5, but we have to think in terms of now 2 negative signs. Okay, it does reach to the negative sign because it's in parentheses. So negative squared is positive, and 5 squared is 25. We end up with 1 over 25. Okay, try this one, please. Okay, it's going to have negative 2 raised to the 6th power. We have an even number of negatives, so it's going to be positive. And then when we take 2 to the 6th power, we're going to get 2 times 4 8, 16, 32. This is going to be 64. So it's positive 64. Okay. All right, next problem. And that's going to be talking about simplifying. Okay, so here's a few examples of some maybe more complicated problems. But here we have a quotient that's raised to a power. So what we're going to do is imagine that 1 there. We're going to times that exponent by 2 and times this exponent by 2. We get r to the 1 times 2, 2. S to the negative 5 times 2, negative 10. We'll now take that to the top because it's got a negative exponent. It shows up as a factor. R to the 2 times S to the 10. You try this one. Okay, so we're going to have A to the 2 times 3, 6 over B to the negative 3 times 3, negative 9. Can't leave a negative exponent, your final answer. That comes up top as a factor. A to the 6th, B to the positive 9 is the answer. All right, let's take a look at this one. All right, so we have 7b to the negative 3, all that in parentheses raised to the 2nd power, then b times b to the 5th times b to the 1st. We'll put that in. So I'm going to take and go ahead and distribute that 2 throughout here. Remember, the 7 is to the 1st power. Don't forget the number. So 7 squared is going to be 49, and it's b to the negative 3 times 2, or negative 6. Now on the outside of the parentheses we have like bases. B to the 5th times b to the 1st is b to the 5 plus 1, b to the 6th. Now we have like bases again. We're going to multiply these by adding their exponents, so it's 49 b to the negative 6 plus positive 6. Well, that's going to be 49b to the 0. And b to the 0 is 1. 1 times 49 is 49. Okay, you try this one. Okay. All right, now think about this. We have to treat the negative separate from the y. An odd number of negatives is going to be negative. And this is going to be y to the 5 times 2, 10, times y to the 2nd times y to the negative 12. Okay, so the only number here we really have is like negative 1, so it's still going to be negative, and it's going to be y to the 10 plus 2 plus negative 12. Well, 10 plus 2 is 12, so we end up with negative y to the 0 power. Now y to the 0 power is 1, so we end up with negative 1 times 1, or the answer is negative 1. Okay, let's take a look at this example, a little more complicated. All right, let's take a look at this exponent on x is to 1. So we're going to say 2 times 2 is 4. 2 times 1 is 2, so x squared, y to the 4th, over, this comes over unchanged. Now what we're going to do is we're going to take a look at this as in 2 parts. I'm going to look at this as dividing like bases here with x, so it's x to the top minus the bottom, or x to the 2 minus 3. And then y to the top minus bottom, y to the 4 minus a negative 1, which we know is going to be plus a positive 1. So we have x to the negative 1, y to the 4 plus 1, 5, and you can't have a negative exponent your final answer. This is part of a fraction. The x to the 1st goes to the bottom, and then to the 1st power disappears. We end up with y to the 5th over x. Okay, you try this one. All right, so we get rs squared. Nothing's happened in the numerator just yet, and in the denominator we'll distribute the 3 and multiply it by the exponent, so we have r cubed s to the negative 3. We'll then look at it in 2 parts. We're dividing like bases with the r to the top exponent 1 minus the bottom exponent 3, s to the top exponent 2 minus the bottom exponent negative 3. Minus a negative is plus a positive. That's equal to r to the negative 2, s to the positive 5. Can't leave a negative exponent in your answer. That's got to move to the bottom, and what we get is s to the 5th over r squared. Okay, that's the end of the video. Thanks for watching, and I'll make an assignment for my class.